Hi, in this video we continue our discussion on frequency distribution table, and we consider this time the frequency distribution table of a quantitative variable. In quantitative variable, on the contrary to qualitative variables, we have many values. In case of quantitative variable, the range, which is an interval starting from the minimum and ends at the maximum of the variable, should be divided into certain segments, parts, classes, or categories. Once that is done, we are back to the case of qualitative variables, where we have certain categories for the quantitative variable. This process is called categorization or segmentation. There are two scenarios in segmentation of quantitative variables. First, the segments are predefined based on a theory, law, or policy. For instance, score range is segmented to define grades. Income is segmented to define socioeconomic class of the people: poor, middle class, rich, or upper rich. Number of secured credits by students is segmented to define students' class level, such as freshman, sophomore, junior, and senior. Age is segmented to define different age categories, such as infant, children, teens, adult, and so on. For example, consider the score of students given in this table and study their grade and score distribution. Here you see we have the score of a number of students. In order to study their distribution, what we do is, first of all, we sort the scores from the largest to the smallest, or vice versa, doesn't matter. Then we use the definition of different grades, starting from F, D, C, B, or A, to categorize, study the distribution of the grade of these students. Consider the range of the score, which is starting from 0 and runs up to 100. And we know that the F score is between 0 and 60. A student is failed. Here in this case, in our data set, we have one student who got a score in this interval. A score between 60 and 70 is D, and we have 3 students in our data who got a number between 60 and 70. And between 70 and 80, we have grade C, and we have 6 students who scored between 70 and 80. And the scores between 80 and 90 is B grade, and we have 4 students who scored between 80 and 90. And finally, scores between 90 and 100 is A grade, and we have 3 students who secured a score above 90. As you can see, we have defined the segments of the scores based on a predefined grade definition. And then we have counted the number of students based on their scores in each segment or in each class. Putting this visual graph in the table, we have the following. We have 5 classes. The first class is for the F grade, representing the score from 0 to 59. The second class is D grade, C grade, B grade, and A grade. The absolute frequency of the class is the number of students in that class. We have 1 student in the F class, 3 in the D class, 6 in the C class, 4 in the B class, and 3 in the A class. In total, 17 students. Relative frequency is calculated by dividing the absolute frequency by total. And the percent is achieved by multiplying this fraction by 100. We have 5.9%, F 17.6%, D, and so on. The cumulative frequency is the relative frequency of the class plus the relative frequencies of all classes coming before it. And since we do not have any class before class number 1, therefore the cumulative frequency of class 1 is the same as the relative frequency. In the second class, though, the cumulative frequency of the second class is the relative frequency of the second class plus the relative frequency of the first class. The cumulative frequency of the third class is the sum of the relative frequency of the third class and second class and first class. Likewise, the cumulative frequency of the fourth class is the sum of the relative frequencies of the fourth class, the third class, the second class, and the first class, and so on and so forth. In the second scenario, where the classification is not defined or there is no rule defining the classification, we have to define the rule ourselves. To this end, we have to follow certain steps. In particular, first, we have to order the observations, find n, which is the total number of observations, specify the range, that is the interval starting from the minimum, ending at the maximum, and finding the length of the interval, which is the maximum minus the minimum. In step 2, we have to specify the number of segments or the number of classes, which we show by the small letter n, and specify the length of each class, which is L, which is the length of the range divided by n, which is the total number of classes. Remember that depending on n, which is the total number of observations, and L, which is the length of the range, usually the number of classes, which is small n, is between 4 to 12, or we can find it by the square root of capital N. Third, once the segments are defined, we are back to the case of qualitative variable and we count the number of observations in each class. To make the things clear, let's consider the height of some individuals in the following table and try to construct the frequency distribution table of these observations. To make the things clear, let's construct the frequency distribution table of the height of some observations which we have here. First, order the observations that we have on the height. We started from 160, which is the smallest, up to 180, which is the largest. There is no difference between sorting in ascending way or descending way. Then we find the range, which is the interval starting from 160, ending at 180. The length of the interval is 180 minus 160, which is 20. And the number of observations is 8. In the second step, we specify the number of classes, which is n is equal to the square root of capital N, which is the square root of 8 because capital N is 8 and the square root of 8 is nearly 3. Hence, we divide our observations, our 8 observations, in 3 different classes. Furthermore, we calculate the length of each class, which is L over N. L we know is 20 from the first step, N is 3, we know it from here. 20 divided by 3 is 6.7. Now we construct the table. In the table, of course, we have 3 classes based on this n, small n here, class 1, class 2, and class 3. And we have to specify the limits of each class. The first class starts from the smallest observation and ends at smallest observation plus the length of the class. That is 166 plus 7, which is 160 plus the length of the class, which is 6.5. The second class starts from 166.7, which is the ending point of this previous class, plus the length of the class, which is 6.7. That is 173.4. The last class starts from 173.4 and ends at 180.1. Remember that the upper limit of the class, you can include it in this class or in this class, depending on your test. Now we calculate the number of observations in each class. In 160 up to 166.7, we have 3 observations, and those are 160, 165, and 165. In the second class, which is 166.7 up to 173.4, we have 1 observation, which is 170. In the last class, we have 4 observations, which are 176, 176, and 2 180s. The relative frequency is calculated in the same way as we did in the previous examples, and as well as cumulative frequency is calculated by the sum of relative frequencies.